Hello everyone, I'm Sreekanth. We are discussing about programming in C language, that to be program fundamentals. So agenda of this session about difference between machine language and assembly language. See what is the major differences between machine language versus assembly language with suitable examples. We try to discuss. Okay. See, what is the machine language and assembly language differences? In machine level language, the level of programming language in machine level language ranks at the lowest level programming language. See, instructions are executed directly via the CPU, Central Processing Unit. Coming to assembly language refers to a low level programming language that needs a translator called assembler for converting the instructions to what? Machine or object code. See, coming to the comprehension, machine language cannot be deciphered by humans and can be comprehended only by the computer. It means the humans cannot understood directly by this machine language. Very difficult to understand by that zeros and ones representation, hexadecimal format, or zeros, complete the code in the form of what? Zeros and ones. That to be what? 8-bit representation. Minimum what? 8-bit representation. Okay. Very difficult to convert that high level instructions into what? Machine understandable instruction. In assembly language can be understood, used and applied by what? Humans, because here everything in the form of what? Mnemonics. Coming to the syntax, machine languages comprise of binary digits, zeros and ones representation. But in assembly language, have a syntax that is similar to what? English language, represented by what? Mnemonics. Like directly we are giving instructions instead of giving completely in a machine level, but here we are given intermediate level like add, load, subtraction, multiplication. We are giving in the form of what? Mnemonics. Dependency, machine languages are platform dependent and their features vary accordingly. Why? Because here completely it is what? Architectural dependent, machine dependent. But coming to the assembly languages, assembly language comprises of what? Standard instruction sets. Areas of application, machine languages serves as a machine code only, but assembly languages are used for what? Real-time systems and microprocessor based applications or devices. Usage of mnemonics, machine languages use sequence of what? Bits for giving what? Commands in the set of on or offset, zeros or ones representation. But assembly languages does not require users to remember op code. It uses what? Mnemonics, like names and symbols rather than what? Raw sequence of bits. Generation of programming language, machine languages the first generation of programming language. Machine languages are used in the first generation of programming language, but assembly languages are used in what? Second generation of what? Programming language. Modification, machine languages does not support any changes, but assembly programming languages can be modified easily. Risk of errors, the risk of errors existing in the syntax of machine language is high, but the risk of errors existing in assembly language is what? Comparatively low. Memorization, binary codes cannot be memorized, but assemblers is need for the proper execution and memorize the command given in a assembly language. Compiler, no compiler is necessary for what? Executing the commands. An assembler is a translator, is needed for the proper execution of what? Assembly language commands. Example like machine level programming language. Here examples like assembly languages like MIPS, MIPS, like NASM, Netwide Assembler, 6 x86 assembly language. These are all what? Examples of what? Assembly language. Okay, so in the machine level language, you need to remember about here two things. One is called op code. Okay, in the previous video session I explained, right? Op code. Op code you need to remember. Okay, this op code is nothing but what? Operation code. Op code is the part specifies the function of the instruction that is to be performed by the computer. Okay, and another one is called operand. You need to remember about another one called operand. So this operand reference what? Address or location. Okay. So everything in the machine level language represented by what? Representation of zeros. That to be what? Minimum 8 bits, like that. Okay. So coming to the assembly language is what? Second generation languages. Here it going to be represented by what? Symbolic operation code. Okay. So they're completely what? Machine opcode. Here you are going to be represented what? Symbolic operation code. Okay. Symbolic operation code and symbolic address information. See, symbolic opcode and symbolic address information is going to be using in what? Second generations, especially what? Especially what? Assembly languages. See, these are all the major differences between what? Assembly level language and machine level language. Remember, machine language always understood what? Zeros or ones representation. The states like on or off, represented by what? Binary representation called zeros and ones, minimum 8-bit representation. Okay, here you need to remember about opcode like operation code and operand, address or location information. But assembly language is a intermediary level language. Here assembler is the translator, is going to be converting what? Assembly level language into what? Machine level language. Here you don't need to remember complete machine code. Here you are going to be using what? Mnemonics like add, subtraction and so on. Here we are using what? Symbolic representation like opcode, symbolic opcode and symbolic address information. So this is a major differences between what? Machine level language and assembly level language. Some differences I wrote in the tabular format. The machine level language comes at the lowest level in the hierarchy. So it has a zero level abstraction level for the hardware. Assembly level language comes above the machine language, means that it has a less abstraction level from the hardware level, but it provides abstraction comparing to what? Machine level. Hardware level what? Less abstraction. Machine language is very difficult to understand by the human beings, because here machine understands only zeros or ones representation, binary code or machine code or object code. It is very difficult by you understand by the human. Here human every time convert high level instructions to the machine understandable instruction. Machine takes that instruction as an input, process it, and it gives output as a machine code. Again end user or human convert that machine code into what? Like user understandable code. Very tough job, very tough to convert and understand by the machine understand to what? Human understandable code is very difficult to convert it. That completely taken by what? Human only. But assembly language, it is easy to read, write and maintain, because here one language translator is there, that is called assembler. Assembler is responsible to convert this intermediary language into what? Machine code. Okay, here intermediary language is called assembly language, that is generally represented by what? Mnemonics or short codes. Okay. Next point, the machine level language is written in what? Binary digits, zeros and ones. The assembly level language is written in what? Simple English language like mnemonics. So it is easily understood by the user. In machine level language, it does not require any translator, as a machine code is directly executed by the computer, because in machine language we are not using any language translator. Directly the machine understandable code we are instructing to the machine. Who is responsible to convert that high level instruction to machine level instruction? Complete job is done by what? Human or programmer or user, used by this machine level language. But in assembly language, the assembler is used to convert the assembly code into what? Machine code. Here language translator is there. Assembler is a language translator. It's going to be convert what? Assembly code into what? Machine code. Machine level language used in which generation programming language? First generation programming language. Assembly level language is used in what? Second generation programming language. Machine language is what? Completely low level language. Assembly level language is what? Intermediary programming language. It is top of what? Machine level language. Machine level language is only understood by what? Computer language like zeros and ones format. Assembly language is only understood by what? Human beings, not by the computers. Okay, because these languages are what? Intermediary language. It is the top of what? Machine language. In machine language, data only represented with the help of what? Binary formats like zeros and ones. But in assembly level language, it can be represented with the help of what? Mnemonics, like such as move, add, addition, subtraction, like end, like we are giving directly instructions in the form of mnemonics. Assembler is a translator, convert this assembly level language into what? Machine understandable language. Modification and error fixing cannot be done in a machine language, but modification and error fixing can be done in what? Assembly language. Machine language is what? Very difficult to memorize, because here you need to like memorize about opcode addresses, operand information. Very difficult to memorize. Here easy to memorize the assembly language because some alphabetic and mnemonics are used. Here everything is what? Symbolic operation code and a symbolic address are used, like add, sub, load, store, load B, add C, store D, like that. Okay. Machine language is very difficult to memorize. Here assembly language is somewhat easy to memorize comparatively machine level language. Execution is fast in machine language because all data is already presented in what? Binary format. But that execution environment need to created by human, that makes very more effort and more time taking process. Execution is slow as compared to what? Machine language, because a translator is required. Translator is converting that high level instruction to, means assembly level instructions to what? Machine understandable instruction. Here machine language is what? Hardware dependent, architectural dependent, system dependent. Okay, machine language is completely depend upon what? Hardware dependent. Assembly language is what? Completely depend upon what? Machine dependent, and it is not portable. Portable means we cannot carry this assembly code, cannot run in what? Other platforms. Why? Because assembly language is completely still in what? Low level language. Okay, even though it is top of machine level language, but still it comes under low level language. It is depend upon the machine. For that sake, you cannot carry that assembly code, you cannot run in the different platforms. So this is about major differences about what? Machine level language and assembly level language. Okay, see, that's it for the today's session. We discussed in detail about what is machine level language, understood only zeros and ones representation, and assembly level languages is made up of what? Top of the machine level language. Here language translator is there in the assembly level language, like assembler. Assembler is responsible to converting what? Assembly level language into what? Machine understandable language. So this is about difference between what? Assembly level language and machine level language. Thank you all. Thank you for watching my video.